Each year, DOT maintenance crews and contractors stripe mile after mile of roadway with waterborne traffic paint. A bright and visible stripe is essential to driver safety, and its performance relies on a high-quality, fast-drying paint.
Hi, I'm Cindy Randazzo with Dow Coating Materials. We've been developing ingredients for traffic paint for over 30 years, and we understand that dry time is a critical measure of traffic paint's performance and quality. Today we're going into the lab to demonstrate a testing protocol for early dry speed.
ASTM standard test method D711 provides a procedure to determine how long it takes for traffic paint to dry to the point where there is no pickup or tracking when a car tire runs over it. This test is a proxy for no-track testing on the road. It's a critical quality control measure that tells us whether or not waterborne traffic paints contain quick-dry technology. The D711 method has been revised in recent years to address the need to more closely control key variables, such as airflow, humidity level, and wet paint film thickness. The revisions allow you to more reproducibly test your traffic paints for no pickup in the lab and have more confidence in their performance on the road. Most DOT labs already have all the equipment they need to quickly and easily conduct the revised dry to no pickup test. You will need a test chamber, also known as a humidity box. This is a key update to the testing protocol. It is used to control humidity and airflow, which are two environmental conditions that significantly affect the dry time of waterborne paints. If your lab does not have a test chamber, you can contact Dow Coating Materials for assistance in obtaining one that complies with ASTM D7539. You will also need a hygrometer to monitor the relative humidity inside the test chamber, and a thermometer to monitor room air temperature. The hygrometer should be accurate within plus or minus 3% relative humidity and provide a range from at least 20% to 100% relative humidity. This test method also requires a drawdown blade with a 20 mm clearance to ensure a consistent wet paint film thickness. Finally, you will want to have an ASTM D711 wheel and ramp to approximate the weight of a tire passing over a painted stripe. Now you're ready to start your test. First, make sure that your testing area is at a controlled temperature, approximately 66 to 72 degrees Fahrenheit, and use a thermometer to make sure that the temperature remains at this level throughout the duration of the test. The next step is to prepare your test chamber. Place the hygrometer inside the chamber and within easy view. Fill the bottom of the chamber with enough water to cover the entire surface to a level of approximately 1/4 inch. Close the door and ports and allow equilibration to the desired level of humidity. Given the importance of dry speed, we recommend establishing a relative humidity level of 90%, plus or minus 3%. This level provides a challenging drying condition that will clearly identify the fastest drying paints. To adjust to 90% humidity, open and close the ports on the sides of the chamber. Ideally, you want the size of the port openings to be about the same on both sides of the chamber to equalize the air circulation in the chamber. Once the humidity level is set, you're ready to work with your paint samples. In addition to the paint that you wish to evaluate or qualify for road striping, the revised ASTM D711 recommends adding a pass control paint to your test method. This should be a paint with a proven pass record for dry to no pickup. If you are in need of a pass control material, contact Dow Coating Materials for assistance. For this demonstration, we are using a pass control paint that contains FASTRACK HE5030 polymer with patented quick dry technology. Our test paint for this demonstration contains Roplex TP257 polymer. This polymer does not contain the quick dry technology. By selecting these paints, we can show the wide range of dry to no pickup results that are possible depending on the type of polymer that's used in your paints. The next step is to prepare drawdowns of your two paints. The wet film thickness is a very important variable that needs to be controlled to get reproducible results. For our demonstration, we are using a drawdown blade with a 20 mm clearance or gap that lays down about 13 wet mils. Immediately place the panel with the wet paint film in the humidity chamber and record the time of application, or use a timer. Follow the same method to prepare your second drawdown. You want to label each glass panel to keep track of your samples, and you want to use the same or similar 20 mil drawdown blade to maintain a consistent wet film thickness. For most replicable results, it's best to limit your tests to 2 paint samples at a time. Testing of more than 2 panels at one time will introduce more variability in results due to poorer control of drying conditions. Once you've prepared your second drawdown, immediately place it in the test chamber. You'll want to put it a few inches away from the first panel so air can circulate freely. Both panels should be in the center of the chamber to avoid airflow variability near the side ports. Controlling the length of time in the test chamber is a critical part of this test and should follow the specifications established for your test paint. In this case, the recommended humidity chamber exposure time for traffic paints made with FASTRACK HE5030 polymer is 50 minutes at 90% humidity. This recommendation is consistent across all FASTRACK polymers, and test results will be comparable across the product line. With your paint samples in the humidity chamber and your timers set, you are ready to set up your ASTM D711 wheel and ramp. At the prescribed maximum no pickup time in the specification, remove your test paint sample from the humidity chamber and place the glass plate against the ramp. Release the wheel so that it freely rolls down the ramp, across the paint film, and onto the black paper substrate. If the test paint has paint adhering to the rubber rings of the wheel or deposits paint onto the black substrate, as we see here, this is considered a fail. It demonstrates that your traffic paint probably does not contain quick dry technology, and it may be lacking in other key performance properties. After reaching the prescribed exposure time for your pass control sample, remove the glass panel and repeat the process. Place the glass plate against the ramp and release the wheel so that it freely rolls down the ramp, across the paint film, and onto the black paper substrate. Here we see that our pass control paint, made with FASTRACK HE5030 polymer, has no paint marks on the black substrate. This is considered a pass. It shows that you are getting a quick drying paint with performance properties that are needed to produce a bright, visible, and lasting stripe on the road.
I'm Cindy Randazzo with Dow Coating Materials. Thanks for watching.